Okay, so we're talking about the big picture. Why are we learning this stuff? Big picture. You are here, and there is the sun, and can't you see it there?
No.
Each of those little white specks in there is like a star, just like our star. I know that by now you've figured out that when you look up in the sky and you see the stars, that those are actually suns, and they are a long ways away. Okay, now sun is not the right word because sun is our star. There's other big ones. Can you name any other stars?
Betelgeuse.
Betelgeuse, yes.
Polaris.
Polaris is another one. What?
Aldebaran.
Aldebaran. I'm going to take your word for that one. I hadn't heard of that one. But there are some monstrous stars out there. Canis Majoris is one of the coolest ones, just because I like the name. You know what Canis is used for? It's like the Latin word, I think, for wolf or dog. And Majoris, doesn't that sound sort of like major? And so basically it's like the big dog. And there are some suns out there, or some stars, that are so much bigger than our sun, it's hard to even comprehend. First of all, just for perspective on how big our, here's the sun. Here's Earth. It's like that big. Seriously. And we're going around the sun, and we're obviously not that close perspective-wise, or all we'd see in the sky is the sun. So we're like way, like over here. Like way. I can't get off the screen far enough. And then picture that, us going around the sun. So I'm going to move my sun like way over here. Just have to still keep perspective here. And it's like we're going around the sun, and it's still a lot farther than that apart. If you take that gigantic circle that it makes as we go around the sun, you can picture how big that is. Double that, and you're still not as big as some of the stars that are out there. Take this distance all the way around. So again, I'll shrink it up here. Just if it was like this and we were going around it, it's not anywhere near like only that big. It's like if I zoom way out, it would be like here's the sun, here's the Earth, and you can't barely even see it. And we're in this elliptical orbit around this. And then you take that and you double it, and that's how big some suns are out there. In fact, they're even way bigger than that. There are some suns that are so big that if I put it on my screen, like the star, that our sun would look like this in comparison. So anyway, there's some massive stars out there. So big picture, that's where you are. Now in the medium big picture, you are in this part of the tree of life. You're born, and then this is the part, I don't know if you can read this, where it says you leave college, and you go out into the rest of your life after college is up there. And this is just somebody's idea of, it's kind of like artwork or whatever of their life. And you are here. You are somewhere in this part before you get to college, and you're learning a little skill. Why is this particular skill so important? Because it's going to be one of those skills that will flow all the way through up into college, into your math classes. Factoring is going to be a huge one. There are some things that you learn that you kind of learn them once and they go away. But factoring is a really big one. All right. So finding the roots, that's a big one. So if I didn't know how to factor, I wouldn't be able to do this. And if I couldn't do that, I couldn't tell that the root was -1. Why is that so important? Well, quadratics, that's like one of the really biggest things that you do with quadratics is find their roots, which are the same as the zeros. Now I know that this -1 would actually go in here and make this equation equal 0. That's what a 0 is. Okay, if I actually multiply that all out and add it all together, it equals 0. All right, it's also good for simplifying. If I factor this, x plus 1 over, help me out factor in the bottom, x plus 3, x plus 1, good. Then that and that will cancel, and now I just have x plus 1 over x plus 3. By the way, did you know that when you graph this, that the fact that this cancels on the top and bottom creates a special thing in the graph. Creates an empty spot. So if you were graphing along on your graph and it's kind of looking like this, and you come to this spot at -1. So let's say the other part of the graph is like down here. At x is -1, there's which is right there. You go down, there's an empty spot in the graph. All right, anyway, so when you're factoring, it helps to be able to cancel and simplify things. And the last thing is, if I take the same exact problem and ask, what can't x be? Otherwise, the whole system will crash. Close. No, it can be 0. It can't be -3. And when you said 0, maybe you meant the whole denominator can't be 0, and that's true. We don't want the denominator to be 0. If I put in a -3, do you get how that would make it 0 on the bottom? And do you get how when you have something over 0, like 25 over 0, that's a problem? Because you can't have divide by 0. It doesn't exist. It says, your calculator would say error. Okay? You can have 25 cookies and divide by 2 people, and each person gets what? 12.5 cookies, all right? But if you have 25 people, we can even divide by 1/2. What does that mean? I have 25 cookies and I divide it by half? The way to think of this is divide it into halves. How would if I had 25 cookies and I divided them into halves, I would have 50. Exactly. All right. 50 parts. All right. Now, if I have 25 cookies and I divide it into amongst 0 people, you can't do that. That's subtracting 0. That's different than dividing it into parts. How about this? Maybe this example works better for you. If you had 25 and divided it into half parts, the parts are all halves, then this one, the parts are all zeros. You basically have to make your cookies disappear. Dividing by 0 should make your cookies divide into parts that are 0 big. All right, anyway, not supposed to do that. So the point is, when you factor, you end up needing to be able to find these zeros on the bottom, and that gives you your domain restrictions, which you'll learn in pre-calc. So I was going to try to start with the easiest of all factoring, and I was thinking that was kind of the kind, but it's not that actually. I can factor 8, the number 8. 2 times 4. I just factored. See? It's factored. The point of the factors is that the two things will multiply together and make the original thing. They are things that would multiply and make it. So then now let's go to this one. What would this factor into? X times, no, but you're close. 2x. There you go. All right. So that makes 2x squared. So now they're factors. This times this will make that. All right. How about in this top one? What comes out? I want you to do this one on your paper and factor it. It's not quite as simple as it seems up front. Try it. Okay, in the back row. Okay, and that brings up a really good point. If I multiply this out and it works, then you have factored it, but you have not factored it all the way. Because, see, that makes 2x squared. The outside and the inside will cancel, and the lasts make -2. It looks like it's perfect, but here's the thing. You see that there's an extra 2 buried in both of those? That comes out to the front, and what do you have left? X minus 1, and then this comes down, x plus 1. That is the right answer. Some of you just factored the 2 out, I know, and said this, and then didn't even think about the fact you could factor that. Okay. How do you do that? That last part? Is that what you're... Oh, okay. All right. I know because I've taught this a long time, and it happens really, really common that people forget to factor it all the way. And the thing that's funny is it'll happen again this hour. People will forget to factor it all the way because it's just a natural thing. You think, okay, I did this big process and I got this answer, and it seems like it's done, and so you think you're done. You don't think about the fact that it could maybe go farther. All right, next one. Does this look like a perfect square? Does this look like a perfect square? And that means that I could break it into the square root of this, which is what? And the square root of this, which is, and then what? A minus and a plus. And even though the numbers are backwards and it may feel backwards to you, as long as when I multiply it out it gives me the right answer, I'm good. It's 3 times 3, 9. Outside and inside are positive and negative 3x, they cancel. The lasts make negative x squared. Works. Okay. Factoring, I think we've practiced enough of these. This is, well, actually I do want to kind of step you up one at a time. This is the kind where there's a 5 in everything. Right? Once that 5 comes out, then you have x squared plus 2x plus 1, and then that's factorable. X plus 1, x plus 1. All right? Okay. Would you factor that one, please? 3x squared minus 5x plus 2. That's the kind where you got to start with a 3x and an x. If you are not good at this and you need practice on factoring, factoring is something that you need to get good at. And you need to take now as your chance to do that. And if you need extra like help above and beyond this, you can come in the morning. I'll gladly work with you on it because it's so important. And the last thought I'll give you is if you want to learn a basic skill like this, there's a website that's pretty cool for this kind of stuff. It's called Khan Academy. I give one example, like in my Algebra Ninja thing. The thing that's cool that on Khan Academy is that he's got this website now. He got funding from Bill Gates, and so he was able to do a whole bunch of cool stuff. He's got this website now where you can like get tested out in different areas. And he'll give you 10 questions and see if you know how to do that kind of thing. And if you do, he tests you out and like gives you points for that. And you can go to the next area. So you could practice factoring there at Khan Academy. You spell it this way. Khan, and then the word academy.org. Okay? Check him out sometime. He's pretty cool. He was featured on USA Today, all the big news networks and stuff, especially around the time that Bill Gates gave him funding. He's pretty much a genius from MIT and Harvard degrees. Yes? Got the answer? What do you got? And minus what? All right, so now I'm going to double check you by going, that's 3x squared. Outside, -6. Inside, +1 makes -5 total. And the last make -2. Yay, you did it right. See how you can double check yourself on all these? It's true. It'll help on the test to double check yourself. All right, this kind, factor by grouping. About a week. Probably have the test right before you go on break. Not sure. I'll give you more specifics when I know. Do you remember how 2 can factor out of this and an x squared? And then what's left in the at the beginning of this, like right here? 2x, good. And then if there's nothing, if I take it out and it's gone, really what I'm doing is dividing by 2x squared. And it cancels and makes a 1. Okay? This next part, people get stumped sometimes because they're like, nothing comes out of that. Well, if nothing comes out of it, you can always take a 1 out of it. It's kind of cheating, but then it'll work. because then that and that are in common. They can come out to the front, 2x plus 1. And then what do I have left? This and this. All right. And now, how many of you had that right answer? All right, good. That's most of you. So if you didn't get that far, at least you can get this part. How do I make this equal 0? That's called the root of the 0. X would be negative 1/2. And if that doesn't just come to you naturally, you set this equal to 0. 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. Okay? How about the other side? You can't make this 0 unless you use what kind of numbers? Imaginaries. Same deal though, set it equal to 0. 2x squared equals 1, no, negative 1. X squared equals negative 1/2, and then I'd have to finish that. There you go, square root, and absolute value of x. Don't forget that. That happens in pre-calc all the time, and kids forget it and they lose points. Equals I, because it was negative. And then the final answer is, you can say plus or minus. Plus or minus I root 1/2. That's how you get imaginaries. The negative came out and we gave it an I instead. As soon as this I appeared, it's because we figured that I was the square root of negative 1. All right, so I want you to try this one. X minus 4 and x squared plus 7. Tell me what the roots are. The first one's easy, it's 4. I want the other ones. Don't say them, write them on your paper. We'll see how many of you get it right. But you say, you can't make that 0. Yes, you can if you use imaginaries. If you were going to jump right to it, all at once, you go plus or minus I root 7. Raise your hand if you knew that. Okay, good. Then, here's factor by grouping again. I skipped the absolute value as a step in here where I would have the absolute value, but then that's what brings in the plus minus. Okay. This is a factor by grouping. I think you're good enough at those. Do we need to do any more of those, or are you good on those? All right. If you need more help on that, ask me. This is the new stuff, rational root with synthetic. Okay, rational root is the F-con over F-co. I want you to write this and figure out what they are and what the answer is. What are the possible roots for this problem? Try it right now. What are the factors of the constant? Mm-hmm. Good. Just can say it once. 1. And Mr. N factors the coefficient. 4. And what else can go into that? Here's the coefficient. Come on. What else can you multiply to make a 4? 2 times 2 makes a 4. What else can go into a 4? 1. 4 and 2 and 1. Okay. So that's the factors of the constant. The constant's right here. And the coefficient's right there. And now it's, don't forget plus or minus on the whole thing. Okay, now, what's 1 divided by 4? 1/4. What's 1 divided by the 2? 1/2. And what's 1 divided by the 1? 1. And it's plus and minus of all of those. Do you understand how I got those? All right. Then, we'd have to test them. 1/2 and 1/4 are a little bit of a pain. So if we were going to test 1 or negative 1, and I put it in a little blank like this, and I go 4, 6, 4, 3, 1, can you tell me right away is that going to work or not? That is not going to work, because when they're all positive, and I'm only multiplying things and adding things, isn't it just going to get bigger and bigger and bigger and bigger? See what I mean? So you're not going to have that work. All right, so then what? Let's try negative 1. Test negative 1, see if it works. Use synthetic right now. One and a negative 1 makes 0. It ended with a 0. If you did it right. So what does that mean? It works. And that can be made into a factor of x plus 1. And this part right here, do you remember how to do this again? The 1 is just the constant. Then this is 2x's, 2x squareds, x cubes. And then I put a little plus in between each term. And there we go. So would there ever be negatives? If there was a negative number, like if we had a negative number right there, then there would have been a minus in there. Other than that, no. All right, so then the next step is, nobody even asked this. Can that factor? If it can, then you have to go farther. In this case, though, I don't think it does. Does it? Oh, it does. Okay, awesome. So then it's x plus 1, and then this would factor into 2x squared, and then 2x plus 1. Yeah, that's right. And then this was the 1, 2x plus 1. And then it's, this x plus 1 is still here. And then 2x plus 1. And then what's left over is that and that. 2x squared plus 1. And there we go. Whew. All right. Except we didn't have this part of it, right? All right. So now, bottom line, there's my answer if they just want it factored. But what if they want the roots? Well, this root will be really easy. What's that? Negative 1. How about that one? Negative 1/2. And that one was the one where we did plus and minus I square root of 1/2. Yep. Okay, that is the kind of stuff you have for today, except you now have the biggest problem you've ever factored before. It's got 6 parts. Factor it. This could potentially take up more than a whole page. Yes, it could. There's a lot of roots that you'd have to test. Now, if you got unlucky and didn't find it right away, for right now, let's just figure out what are the roots that it could possibly be. What are the numbers that could go in the little box for synthetic? Well, you need f con over f co, right? What's the factors of the constant? 2 and 1. What's the factors of the coefficient? And then, what do I do with these things? Divide them. What's 2 divided by 4? What's 2 divided by 2? What's 2 divided by 1? What's 1 divided by 4? What is 1 divided by 2? I already had 1/2. And what's 1 divided by 1? Already had 1. So there's my list. Those are all the things that you'd have to test. Now, I'm going to have is, let's divide and conquer, so to speak. Let's divide this up and have different people test different things. Okay, I want this row over here to test positive 1/2. You guys test negative 1/2. You guys test positive 1. You guys test negative 1. You guys test positive 2. You guys test negative 2. I'll tell you right now, it's one of those things. One of you, it's not the 1/4. Yes? Yes. All right. Did you find it with not your own number again? Doggone it. Just test your own number. Let other people have the fun sometimes. He's got a 6, sense for what number might work. All right, so tell me, Mr. Sixth Sense, what number was it that you thought worked? And if -1 is correct, I'm going to test it right now. -1. And then I go 4, -2, -8, -5, -5, -2. And then drop it, multiply it, add it, multiply it, add it, multiply it, add it, multiply it, add it, multiply it, +2, and it adds to 0. You called it. Now, what made you think that -1 would be a good idea? Because there's double 2s and double 5s. Okay. He's saying that he saw that there were duplicate numbers and that there was lots of negatives, and that if you used a negative, that might help the negative to disappear, and that's a good point. Otherwise, your answer would be this giant negative number. All right. Okay, so, yes?
2 works too.
2 works also? All right, so let's see. Let me show you what that means. Oh, I think 2 actually does work. Did anybody try 2 and make it work? All right. And so some of you guys thought you were wrong because, no, it's actually you're both right. Let me show you what I mean. The answer for this is that this part here gives me x plus 1. And then you get how this part right here is, I throw in my x's, x squareds, x cubes, x to the fourths. How come some kids said that x plus, or that 2 worked? Is it +2 or -2, by the way? +2. Okay, if +2 worked, then that means that this one right here could be factored. And guess what one of its factors would be? I don't even know what the rest of it is, but I could do synthetic and figure it out. Because somebody else got the right answer over there? Right. You both were right. 2 was a factor of this. So when it's all said and done, that one worked, and then there's some other thing that probably can be factored even farther, but we've taken enough time on this. The bottom line is you got to keep factoring until the thing is done. I guess I'm just going to go one more step and see if I take the 2 out of this one, then I'd have 4, -6, -2, -3, -2. Draw the line, drop it. 4 times 2 is 8, 2, 4, 2, 4, 1, 2. It worked. Then my answer is, don't forget the x plus 1. And then this one, x minus 2. And then this is x squared, third, plus, and then that can probably be factored again. Divide and conquer. Is that the same one as before? That was come up like 3 times? Awesome. Then it's x plus 1, x minus 2, and that one was 2x squared plus 1, and then, whew, Factorzilla, I like it. Yes. All right. Your teachers have done that before. We have done it in math too, where we've done a problem in class, like thoroughly, and then put the same exact problem on the test. So if you were paying really good attention in class, it rewards you, which actually seems reasonable. All right. Okay, that was it. Your homework is just to take the worksheet I gave you yesterday. This is about factoring. What's it called again? For those that are at home. Yes. It's called Rational Root Theorem. Take this and finish it. I mean Friday. You weren't here, right? Take it just in case.